achieved a level in its development suitably as point of departure of the modern mathematics. My friends, here as a fractional calculus researcher, it is a proud to say that in recently the highly cited researcher list is shortlisted by the Scopus, in which most of the scientists are belong from the fractional calculus area. On the same time, recently Stanford University is published one of the research scientist name list in which they mention that the 2% scientists of the worldwide in 21 research fields. And I am also happy that most of the researchers in the field of the fractional calculus, biomechanical engineering, information technology, and another fields of the engineering and sciences, most of the scientists are belong from the fractional calculus area. And I am also part of the particular list. So by then the theory had been extended to include operator d nu, where nu could be rational or irrational, positive or negative, real or complex. Thus, the name fractional calculus becomes somewhat of misnomer. A better description might be differentiation and integration to an arbitrary order. Into 19 to 2016, or maybe that up to the 2020, it is a practically impossible to name all made important contribution in construction of the early stage of the building fractional calculus. New era in the development of this branch of science began 14 to 50 years ago due to numerous applications of fractional type models and is continue up to now. One can be mentioned a large list of area of application as follows. Fractional operators appear at studying various problem of the analysis of differential equations. And here the Dittlim book is very, very popular. It is one of the, you can say that one of the initialized, if a researcher is started his career in the field of the fractional calculus, then this book is play very important role. Then here I mentioned that the very important and very popular book by the Kilbas, Srivastava and Trujolio. It is a very popular book, and I can say that it is cited by more than 16,000 times by many researchers. Those are working in the field of the spatial functions and fractional calculus, and they want to understand the relation between the fractional calculus and spatial function. Then this book is very, very important, in which the starting chapter is presented for the spatial functions. In these chapter, you can understand how these spatial functions are behaved, in which you find the Metcalfe function, you find the Bessel's function, you find the trigonometry functions. And after the latter half of this book, you find the applications. I mean, how to use these spatial functions in fractional calculus. So it is a very important book. Those are interested to understand the behavior of the spatial functions, then it is also very important book. And I am a fortunate because I got the opportunity to work with the Professor Srivastava and Professor Trujolio. I have a joint paper with both the eminent researchers. Unfortunately, there is a one paper is working with Professor Kilbas, but unfortunately, due to his early die, we are not able to complete this paper. Then here I mentioned that the one of the pioneer mathematicians, I can say that fractional calculus person is Virginia Kryakova. She is a lady, and she is a highly respected professor in the field of the fractional calculus. My friends, in these days, those are working in the field of the fractional calculus. For all of them, she is just like considered as a mother of the fractional calculus. Virginia Kryakova, she developed many works in the field of the fractional calculus. And one of in the 2018, I visited Jordan in one of the biggest conference. At there, the Virginia the Professor Virginia is met with me and then she mentioned that कि Professor Agrawal, your work style is similar to my style. So it is a really great honor for me if I am working in the way of the Professor Kriyakova. But she mentioned many points, many remarks to improve my research areas. And in these days, I am trying to improve my quality of the research, because if she says that ki I am working on her style, then it is a very, very big remark for me. She has contributed many works. Here I mentioned two very important papers from her side. There is one is the Generalized Fractional Calculus and Application, published in 1994, and another one is the On two Saigo Fractional Integral Operators in the Class of the Univalent Function. Then Miller and Rose, this book is also very popular in the field of the fractional calculus and introduction to the fractional calculus and fractional differential equations. Those are belong from the engineering field. Then this book is play the important role to understand the engineering applications. Then Oldham and Spanner, it is also one of the basic book in the field of the fractional calculus, published in 1974. And Podobny, there is a very important contribution by Podobny, the fractional differential equation. It is also useful for the engineers as well as those mathematicians, those are find out the solution for the engineering problem. Then they better understand with the help of this book. Then Sameko, Kilbas and Marchev is published, very, very important and very good publication. It is published in 1993. Basically, this book is compilation of the many kind of formulas, many kind of integral formulas, differential formulas. So it is a very useful book for every kind of scientist and engineers. Those are using the fractional calculus operators. Then here I've mentioned another very important paper by the Machado, Kryakova and Menardi. It is a history of fractional calculus. Basically, the three are the pillar of the fractional calculus, and I got the opportunity to meet with all of three in Jordan. So they compiled one of the volume in which they mentioned that the development of the particular history of the fractional calculus, how it will be born and how it will be developed and how it will be used in all the field of the science and engineering. Then introduction to in field of the physics, there is a very important book by the Hilfer. It is published in 2000. And in the modeling and control, there is another book is published by the group of the researcher in 2010. Then Nano and Cosmic Physics is also published by the one of the two volumes by the Uchkeni in fractional derivative for physicists and engineers in volume 1 and volume 2. So objective, there are many contributors did their contribution in the field of the fractional calculus, but it is not enough to mention it here. So that's why I am going to my objective of my investigation, the extensions of the d nu f and their properties. Then fractional integral inequalities, image formulas, we can say that composition formula also of fractional integral and differential operators. Then applications of the fractional calculus. Now here first I start from the gamma function. This is the Euler's integral formula. We can say that the gamma function is given by the equation number 4. It is a basic definition of the gamma function, and the basic definition of the beta function is given by the bxy equal to 0 to 1 t raised to power x minus 1 and 1 minus t raised to power y minus 1 dt. Now in my joint paper with Professor Shrivastava and Professor Jain, published in 2014 in Applied Mathematics and Computation, in which we generalize the beta function with the help of our confluent hypergeometry function. We generalize the beta function in this form. At here, I am using the generalized beta function in this form. In this integral, you can find that I can compute this integral with the help of the confluent hypergeometry function, right? So this is the generalized form of the beta function. It is easy to mention that if p equal to 0, then confluent hypergeometry function, this becomes 1, and immediately this definition becomes to the basic definition of the beta function. Then in this paper, we also generalize the Gauss hypergeometry function. In this, we are using the generalized beta function, and then we use the some computation and generalize the Gauss hypergeometry function in this form. This is given by this, and these are the convergence conditions. So where the generalized beta function is given is earlier in 4.3. Clearly, for the Gauss hypergeometry function 2fn, we have to find out with the following relationship. This is the well-known Gauss hypergeometry function, and if we can put some specific values of the parameter, then we got this one, right? So this is a basically generalized form. So in our paper, we generalize the beta function as well as Gauss hypergeometry function, and it is a highly cited paper in applied computation mathematics. It is undefined if c equals a known positive integer. Here, lambda n denotes the Pockenberg symbol defined by these definitions. So, with the help of this, after this paper, we can thought how to use this extended beta function and extended hypergeometry function in extension of the fractional operators. So, in my joint paper with Professor Choi and Professor Paris in 2015, we extended Riemann-Livoli fractional derivative operator with the help of our extended beta function, and the result becomes in this form. So, before going to generalize the Riemann-Livoli, we require to extend the Gauss hypergeometry function as well as Appel's functions. So, first we generalize all the hypergeometry functions, and after that we use these extended fractional operator, extended hypergeometry functions in the extension of the Riemann-Livoli fractional derivative operator, which I have shown in the next slides. In this paper, we also extend the Appel's hypergeometry function. This is the first kind of Appel hypergeometry function, and here you can see that this is the generalized beta function, which is generalized by my side and Professor Srivastava and Professor Jain. So we use this extended beta function at here and extended this definition. Then this is the confluent hypergeometry function of second type, and in which I again use the product of the two generalized beta function given by this. And with the help of some computation, we find out this solution. Then this is the Luricilla function. At here, we again use the generalized beta function given by at here, and we find out this beautiful formula. Okay. Then, with the generalization of these all the family member of the spatial function, we go to the extension of the Riemann-Livoli fractional derivative operator. As we all are aware, this is the classical definition of the Riemann-Livoli fractional derivative operator. It is given by equation 5. So, in which you can say that the d nu is z, fz is represented by this right hand side part, and it is valid for the real part of the nu is less than 0, where the integration path is a line from 0 to z in the complex t plane. When real part of nu is greater than equal to 0, and let m's belong to capital N be the smallest integer greater than real part of nu, and so m minus 1 is less than equal to real part of nu is less than n, then the Riemann-Livoli fractional derivative fz of order nu is defined by, this is the second definition. So for this particular condition, it becomes in this form. And when I extend the Riemann-Livoli fractional operator, then I am also using this second definition to extend the Riemann-Livoli fractional operator with the help of the extended beta function. The fractional integral derivative operators involving various spatial functions have found significant importance and application in various areas. This is my motivation. That's why I generalize these functions. And as I earlier mentioned that with the help of Professor Choi and Professor R.B. Price, we journalized the Riemann-Livoli operator, and it becomes in this form. Look at that. This is the beautiful result. This is the definition of the extended Riemann-Livoli fractional derivative operator. At here, we are using this particular confluent hypergeometry function in the kernel and use the some computation with the convergence condition of real part of nu is less than 0, real part of p is greater than 0, real part of kappa is greater than 0, and real part of mu is greater than 0. Then this beautiful result comes at here. So this is the extension of the classical Riemann-Livoli fractional derivative operator. Many researchers, young researchers, are used my extended fractional Riemann-Livoli operator, and they use in the mathematical modeling, they use in some application areas too. So it is a highly cited paper from my side. So in this paper, in this particular direction, we also extend and find out some more results. So the extended Riemann-Livoli fractional operator is also represented by this definition. Also, this is the second definition. Okay, and here is the convergence condition is real part of p is greater than 0, real part of kappa is greater than 0, and real part of mu is greater than 0. Okay. Main result of the paper is formulated as the following theorems. So after the extension of our extended fractional operators, we find out their composition formulas for the variables and functions. As I mentioned that earlier in my early slides, Professor Euler's give one of the very important composition formula. So by using this approach, we use the composition formula of the z raised to power lambda for extended Riemann-Livoli operator, and we got the result in this form. And here it is very easy to understand that this is the extended beta function is introduced by my side. So I introduced in 2014 this extended beta function, and then after a year I use the solution of the extended Riemann-Livoli fractional operator for z raised to power lambda. Then I use this find out the solution in terms of the extended beta function. This is the beauty of the research. You understand my point? When I extend the beta function, I never thought I can use this to find out the solution of the extended Riemann-Livoli operator for z raised to power lambda. But when I found out the solution of the z raised to power lambda for with the help of the extended Riemann-Livoli operator, then during the computation and find out some kind of results, some kind of gammas, and then this result is used. On the same way, every researchers are use their results or maybe the results of the another researcher in the same way. So basically what we are doing as a mathematician, we develop the many formulas, we develop the many kind of integrals, differentiations, and another kind of formulas, and rest of the work is done by the engineers, medical scientists, agriculture scientists, because when they deal with some physical phenomena, then they have some kind of equations, and then to solve this kind of equations they require some kind of known formulas, and here our role is started. If you can see the at international level, most of the researchers are working in the group, but in India, I am really sorry, there is no culture at here. In abroad, it is a well-known culture. In the group, some of are belong from the agriculture science, some are belong from the computer science, some are belong from the electrical engineering, and there are some of the common person are from the mathematics side. So that's why they do the very good research work. And I request to all the young researchers, they can try to develop this kind of to the young researcher. This is my another result in which you can see that with the same extended Riemann-Livoli operator, we develop this particular formula. Okay. in which we develop this beautiful result is given by this equation. Okay, due to the time limit, I am not elaborating all the things. Then we find out the composition formula or maybe the image formula for two variables. On the same approach, we use the some calculation, and here you can find that the extended Gauss hypergeometry functions, the result will comes in terms of the Gauss hypergeometry functions, right? On the same time, for the three variables, we use the same way, and here we find the solution in the Apple function, right? We use the same approach to find out the solution for the four variables, and we find the solution in Luricilla hypergeometry function. So this is the beauty of the research. We can develop some formula, and someday we use these results in some another form. On the same time, someone is developed some formulas, and as a researcher we use their formulas. So this is the beauty of the research. And as I mentioned in my earlier point, Stanford University compiled this kind of data, and recently they mentioned the list. And I think more than 1,500 scientists from the India, they in part of the list, and I am also part of this particular list. So in this particular direction, we also find out the some generating functions, and this is the one of the generating function with the help of the extended Gauss hypergeometry function. Can I ask to the Meher how much time I have? Meher or Dr. Manjeet, can you tell?
Yes, sir, you have time.
Okay, I have time. Okay. Thank you. Thank you. So in this direction, we also develop another generating function for the extended Gauss hypergeometry function. This is the extended Gauss hypergeometry function. Friends, I am not mentioning all the convergence conditions due to the time limit. And after the computation, the result becomes in the form of the Apple function of first kind, right? This is the result. And there are boundary conditions are there. Sorry, not boundary condition. It is a convergence conditions are given by there. Okay. Then after the finding the extension of the Riemann-Livoli fractional operator, we got one of the idea in our mind to find out the Mellin transform of this function, because Mellin transform is giving the asymptotical representation of the function. So we work in this kind of direction, and then with the help of some computation, we find out the Mellin transform of our extended Riemann-Livoli operator, and the result is comes in this terms. At here, the result is come in the gamma function, extended gamma function, and beta function, classical beta function. In the same way, we use some another approach and find out the another Mellin transform of this function. Then it's come in this way. Then we are using the solution to find out in the form of some application point of view. At here, you see that the right hand side result comes in the H function, that is called the Foxius H function. And here I mentioned that in the space science, it is a very, very important function. Professor Humboldt, he published more than, I think, 4 monographs in this direction. And Professor Humboldt is mentioned that, Professor Mathai and Humboldt, they mentioned that the Foxius H function is very, very useful in the space science. When we deal with some space science problem, then the problem becomes in the form of the equation, and most of the time the equation is easy to represent in the terms of the Foxius H function. Recently, one of the legend, though he is working in the field of the Foxius H function, he is died, Professor K.C. Gupta. So I give my condolence for him. He recently died, and he belonged from the Jaipur, and I got many kind of guidance from his side. So he's working in the Fox's H function, and he published a very beautiful book. If I'm not wrong, the name of the book is H function of one variable and two variable and their applications. So it is a very beautiful contribution by the Professor Shrivastava and Professor K.C. Gupta. But nowadays he's died, so it's a great loss of the in the field of the research. Motivated by above mentioned work, we have introduced further extended Riemann-Livoli fractional derivative operators and studied its various property in my joint work by Professor Dimitru Belenu. He is my very good friend. Professor Parmar, Professor Qureshi. In 2017, this paper is published in Journal of Nonlinear Science and Application, in which we use a different kind of approach and we publish this paper. Then extended fractional derivative. In this paper, we use this particular exponential function, right? This function we use at here to find out the extension of the Riemann-Livoli derivative, right? So we use the different kind of approach at here, and the convergence conditions are this, and we obtain some result for the real part of mu is less than 0 is given. Similarly, we further develop another work in the same direction, co-authored by me, Professor Nieto from Spain, and Professor Liu from China, and published in Open Mathematics. The name of the paper is the Extended Riemann-Livoli Type Fractional Derivative Operator with Application. It is published in Open Mathematics. It is a SCI category journal. So Professor Nieto, if I'm not wrong, in these days, recently we talked and he's working for the government of the Spain during the COVID time. Professor Ivan, he is a collaborator of Professor Nieto. So Professor Nieto and Professor Ivan. In these days, Ivan is my very good friend. So both are working for the government of Spain to predict how much, how to manage the spreading of the COVID-19. My meaning is that how much hospitals they required, how much ventilator they required, this kind of things they calculate for the government with the help of the fractional calculus approach. So my friends, this field is very, very important in these days, especially in fractional calculus. Recently, one of the very, very well-known mathematician and medical person, he is Professor Rao from belong from the India, but nowadays he is working in USA, and he wrote me an email and he mentioned one of my paper, okay, Dr. Agarwal, you extended this fractional operator and we deal with this the data, then we required how to compile this data. Then I compiled for him and I hope it will be published soon. So we compiled the statistical data of the growth of the patient, the growth of the COVID, and how to manage the hospitals, how to manage the medical things. So we compile, we manage all the data with the help of our operator, and then we give the data to the Professor Rao, and I hope our this compiling will be in a very good journal. So, motivated by above mentioned work, we have introduced extended Caputo type fraction derivative operator and study its various properties in my joint work in this direction. And first paper will be published in 2017. Professor Kiamaj is my very good friend, and we published, he's from Turkey, and he's a basically applied mathematician. But after discussion with me, he started to work in the field of the fractional operators. Initially, he is working in the differential equations and partial differential equation, PDs. So after my discussion with me, we started a joint work and we create a small group. And I also visited for 1 year in his university as a visiting scientist to obtain one of the prestigious fellowship, to be visiting fellowship. And during our my stay at there, we are discussing many good problems. Some of problems are published, but still some problems are still going on. So in the same way, we also extended the Caputo fraction derivative, and here we are using this extension format here, right? We use the exponential function. The exponential function is given by the e raised to power minus pz square upon
Excuse me,
t.
dear professor, we have 5 minutes more.
Okay, okay. Thank you. Thank you. So, with the help of this exponential function, we generalize the Caputo fraction derivative operator, and we find out the many results. And I also got the opportunity to work with the Professor R.P. Agarwal. He is from Texas, and we published one of the joint paper in extended Caputo fraction derivative operator, published in Advanced Studies in Contemporary Mathematics in 2015. Still, me and Professor Agarwal is working on some new problems in this direction, and soon our result will be published. So we establish certain new image formulas of generalized hypergeometry functions given by earlier equations by applying to the operator fractional derivative involving the Apple's function. Here, my joint paper with my Meherchan, Dr. Meherchan and Korimo, it is also published in Applied Mathematics and Computation 2015. Uh, Also establish image formulas for Bessel function with Professor Dr. Meherchan. It is a joint paper. And then we go enter into the field of the fractional integral inequalities. I briefly mentioned that the importance of the fractional integral inequalities. During the past 2 decades or so, fractional integral inequalities have proved to be one of the most powerful and far-reaching tool for the development of many branches of pure and applied mathematics. Very recently, many authors have presented some generalized inequalities involving the fractional integral operators. So, my friend, this is another direction of the for the researchers. Those are want to work in the field of fractional calculus. Integral inequalities are very important to understand the behavior of the function, to understand the convergence, more deep convergence of the function. Integral inequalities are very important. If we can understand the behavior of any function, any operator, with the help of the inequalities, then we understand the boundaries of the function, boundaries of the operator. So this is another area, but due to the time limit, I am not giving more detail at here. I am skipping my all these slides, but I am going to the some part which is important. Yeah, these are my papers. Those are related for fractional integral inequalities. So you can go for my ResearchGate page or maybe Google Scholar page, and you can find all my research. Most of the papers are open access. So you can download from there and understand what kind of research we already did. And me and my research group, and Dr. Meherchand is also my member of my research group. So these are my publications, but I'm not mentioning it here. Here I only consider some well-known papers. Okay, so we have many papers, but future approach. This is important. The definition define fractional Q calculus operators appropriately with a view of applying these operators in the geometry function theory of complex analysis. Study and investigating geometric property of such function like coefficient estimation, radii of close to convexity, star likeness, convexity, and destroying properties. My friend, this is the one of the area in which in these days I am working, and those are interested, they are most welcome. My PhD scholar is also working in this direction, and as you heard, there is a quantum computer is soon come. So if we go or we study the behavior of the quantum computer, then Q calculus is very important. Okay. So that's why I am going in this direction to find out some good results. So once again, thank you very much for your patience to go with my talk. And if anyone have any problem, then most welcome. Thank you.
Dear estimated professor, thank you so much for your valuable presentation. You shared very nice and useful information for us. If there are professors who have a question, we can go to the question and answer section. If we are not defended, we can thanks our professors again. Yes, if there is any question, please welcome. I think there is no question, but I have a question for you. In your
Yeah, please welcome.
presentation, thank you. In your presentation, you mentioned that earlier Riemann got useful results and important results on fractional calculus. They also work on number theory and found out significant results. Do you have any idea how can we use fractional calculus in which topics of number theory?
Yes, first of all, thank you, Professor Roger, and it's nice to see you. I am not able to see you, just I heard your voice. Okay, so
Okay.
yes, in the field of the number theory, if anyone knows about the Professor Ken, he's from a vice president of the American Mathematical Society, and last year he visited my place. So during his stay in my university, we are discussing very deeply about how to use the fractional calculus approach in the number theory. So he mentioned the some of the areas at where we can use the number approach of the fractional calculus. First of all, when we find out the conjecture in the field of the number theory, then to find out the conjecture, we can use the approach of the fractional calculus to try to find out their the behavior of the conjecture. So in these days we are working right now, we are working, but I hope in the coming months or maybe the year we find out the some beautiful results. Yes, Professor.
Yes, thank you very much. I'm also working on pure mathematics and number theory and algebra. If you need any support from my side, I will be ready for all the T's, and I will be happy to collaborate with you if
Thank you very
possible.
much, Professor. Definitely, and I request to the Dr. Maharchan keep this welcome invitation from the Professor Mojer side.
Yes, dear professor, she is also connected with me from long time,
Oh,
and she is a
oh.
Yes,
very
now you saw
yeah.
me. Thank you.
Professor Azhar is from Turkey.
Yeah, I know her. I know her.
Yeah.
Thank you very much.
She's a well-known, and many times she sent to the emails and we chat together via email. If you remember, Professor Azhar.
Yes, I know you. We talked by emails. Thank you very much
Yeah.
for your all academical supports for
Yeah.
us. Thank you very much for all.
Thank you very much. Thank you very much, ma'am.
Professor Gurmez is also there, and one student, Daljit Kaur, is also in this lecture.
Yeah, great. So, Professor Roger, for your information, it is my research group, and Professor Dr. Gurmej is also our team member, and Dr. Meher is very active. Dr. Gurmej is very active, and Daljit is the second generation of our group. So they are very active researcher and very young researchers.
Thank you. You too.
So definitely we can try to find out the some kind of areas at where we connect together.
Yes, I will be happy if we find some connections between fractional calculus and the number theory.
Yes, of course.
It will be a nice perspective for scientists to
Yes.
find new significant results and find some important results for literature.
Yes, ma'am. You are absolutely right, Professor. Because last year when I visit to the Germany, then my one of the friend, Professor Jochen Merker, he is also applied mathematics, and Ken is also know to together. Then we discussed jointly, and we hope soon we can find some results, and then we share with you.
Okay, thank you very much. I will be waiting for your email. Thank you
Definitely,
so
ma'am.
much.
Thank you, ma'am. Thank you.
Thank you, dear Professor, for your valuable talk and valuable time to make this session successful. And I hope your talk will be really fruitful for all the participants in this session. Thank you, dear Professor. And now there is a plenary talk by Professor Ozan Ozer. So first of all, I would like to introduce her. Professor Ozan Ozer received her BSc and MSc degree in mathematics from Turkey University and PhD degree in mathematics from Slomia Demirel University from Turkey. Currently, she works as a associate professor in the Department of Mathematics, the Faculty Science of Arts, Kilkerley University. Her research of specialization includes the theory of real quadratic number field with applications, Diplotin and Pell equations, Diplotin sets, arithmetic function, fixed point theory, analysis, Q analysis, special integer sequence, nonlinear analysis, matrix theory, automation techniques, cryptography, machine learning, artificial intelligence, and so on. She has published more than 60 research papers in the high quality international journals as well as many national and international scientific projects. She also has written, published some books and chapters of books in number theory, algebra, applied national and international conference in lots of countries she visited. She has attended various national and international conferences in lots of countries with different kinds of topics. She has worked in the different international journals, more than 55 differential publishing houses and journals as reviewer with the number of editorial board of the books and papers. She is ready and open all kind of academic and scientific collaborations and corporate too. Thank you, dear professor. Now I would like to address your valuable talk.
Thank you so much. I would like to
Yeah, I give you permit. Yes, yes,
share my screen
yes.
if
Please,
possible.
just please wait 1 minute.
Okay.
Yes, dear professor. Now you are host and you can share your desktop.
Okay.
Yeah, we have 40 minutes for this talk. Okay.
Okay.
Yeah.
It is enough for me. Is there any problem to seeing
Yeah,
my
we can
presentation?
see your.
Are you seeing?
Yeah, all the things are okay.
Okay. Dear respected staffs, colleagues, and estimated guests, first of all, I salute all of you with love and respect. I am very sorry for being late to start our session since I was making presentation on primes and the cryptography as an invited speaker for another webinar. You are all welcome to this fruitful international conference. I would like to begin by thanking everyone who has contributed to this conference, presented a paper, participated in scientific and organizational committee, contributed and managed it. This conference will bring together all the people who work in natural sciences, engineering, biomathematics, mathematical modeling, and who are interested in this field, managers, technicians, academicians, researchers, introduces users to share knowledge and experiences, seek solutions to problems, storm and joint action. This conference should be considered as a platform aiming to contribute to the communication of universities and the academic community with each other and society. This conference brought us together. The next one is about how much we can benefit from these conferences. I thank you all for your contributions and wish you a successful conferences. It is a big honor for me to meet with you and share some current researches on mathematics. Before starting my presentation, also, I would like to say thank you so much to Dr. Mihar for his kind invitation and giving me this nice opportunity to meet with you. Today, I will share with you some general informations on Diophantine sets and Diophantes. Then I will explain some new results for such sets. I hope it can be useful for you and we may make collaboration near future. The title of my presentation is Identification of Particular Diophantine Triples. Here you can see my contact informations and you can reach me by email or mobile as you've seen in here. Also, you can see my research topics. I'm not just working on number theory or algebra. I also work on analysis on fixed point theory and other topics of math. From time to time, I update my blog and you can also follow me and contact with me by there too. I have several email addresses you can see and I use all of them, so you can choose any of them to write me for connection. Let us consider abstract of my presentation. There are many interesting and significant open problems in number theory. One of them is Diophantine set. The interest of the topic is to determine characterization and classification of the sets as well as their maximal sizes. The extendability of the Diophantine sets problem has been considered by several great mathematicians who constructed various types of methods for the topic since the date of Diophantus. Now I will give the definition of the Diophantine K tuples with property B beta. Let beta be a non-zero integer and B be a set of distinct positive integers. B is set to be dB Diophantine K tuples for any two different positive integers Bi, Bj of B. If the integer Bi multiplied Bj plus beta is a perfect square integer. These kind of popular sets are useful for many different areas and related with a lot of subjects such as quantum physics, computational chaos, game theory, Diophantine machine, logic methods, computing machinery, Turing machine, etc. This presentation deals with the construction of particular Diophantine triples with the property P minus 10 or P plus 10, and some general forms of Diophantine triples with property P minus or plus 10 are determinant and their non-extendability are proved. Then some characteristic results of the such sets are found out, and several numerical examples are given to support our results. For this presentation, we can use keywords as you've seen, and you can get many documents such as papers, books, and so on to know more about this topic or subject. The organization of this presentation will be like you see. In the section 1, I will mention history of the topic, and used methods are taught from the literature. In the second section, basic concepts and useful results are collected to prepare the main results section. In the section 3, main results are demonstrated. In section 4, some numerical examples will be given which will support our results, and the section 5 will include references. Let us look at the history of the topic and literature review briefly. The mathematician Diophontis started the problem of extendability and characterization of PK sets. Although the topic of Diophantine M table is very ancient problem, still many others have been working on it with different techniques. Many famous mathematicians obtained significant results on Diophantine M tables, but still some problems remain unsolved. This shows that Alexandra Diophontis is very important and famous mathematician who wrote arithmetical books significant for algebra and mathematics. In the beginning of my presentation, I already gave you the definition of the Diophant set with property PK. Diophantine equations and sets have central role in number theory and can be used in coding theory and cryptography. For real life applications, Diophantine equations and sets are useful to solve problems of business, network flow, and so on. I would like to introduce that perfect mathematicians to you briefly. Diophontis is known as the father of algebra. Roughly 5 centuries after Euclid's era, he solved hundreds of algebraic equations in his great work, Arithmetica, his book, and was the first person to use algebraic notations and symbolism. Today, we usually indicate the unknown quantity in algebraic equations with the letter X. Arithmetica inspired some of the world's greatest mathematicians, including Euler and Fermat, to make significant new discoveries. Diophontis begins with the definitions and rules. For example, he defines the results of multiplication of quantities with different signs and tells his reader he will indicate subtraction with a symbol. Diophontus continues in this way, describing hundreds of problems which he translates into solvable equations. The level of difficulty rises as he introduces quadratics, cubics, and equations in higher powers of X. In Arithmetica, Diophontis launched the study of indeterminate equations. These are polynomial equations in which the number of unknowns exceeds the number of equations given. Nowadays, we define a Diophantine equation as an intermediate equation whose solutions must be integers. For example, consider this Diophantine equation x power n plus y power n equals to z power n. If we choose n equals to 2, we have Pythagoras theorem, which has an infinite number of whole number solutions. The most famous examples of which is the 3, 4, 5 triangle, like you see. And also, Fermat's last theorem claims that if n is a whole number bigger than 2, the equation has no whole number solutions for x, y, and z. Diophontus didn't just write Arithmetica, but have very few other works, such as the Prism on polygonal numbers and geometric elements, Diophantine analysis, mathematical notations, and so on. In this table, we can see the lifetimes of some Greek mathematicians who are famous in mathematics. Before preparing this presentation, I decided to reply these main questions, which will be useful for you. We have to reply these questions to understand our topic and to know more about it. First, why do we work on this topic? The second, what is of interest? Third, what kind of areas can we use our results? And the last, why is the classification of Diophantine triples important? The problem of extending Diophantine sets was constructed by the Diophontus, who is the father of algebra. Diophontus studies on the problem of finding numbers such that the product of any two of them increased by the sum of these two gives as a square. He found two triples. The first one is 4, 9, 28, and this triple set includes rational numbers satisfying this property. To know more about Diophontus and his work, you can watch these videos. I will not play them now due to restriction of the time, but you can look at them and know more about him. Diophantine analysis theory is used by number theory, geometric curves, computer science, dynamical systems, calculating economy, control systems, network problems, chemistry, balanced problem, quantum physics, cryptology, and many different scientific areas. That is why it is important to work on Diophantine and tuples. But what about what is interest of? Given the commutative ring, and in this paper, we will work on the commutative ring set of integer with identity element. What is usually interest is the size of the maximal length of m tuples. For example, if we choose m equals to 4, then there are finitely Diophantine quadruples with property P1. In 1979, Erkind and his friends noted some conjectures and theories for Diophantine quadruples, and they demonstrated two conjectures. The first one is weak Diophantine quintuple conjecture. There is no Diophantine quintuple with property P1, and it was solved. It is not conjecture now. The second one, the strong Diophantine quadruple conjecture, is all Diophantine quadruples are regular, and it is still open problem now. Diophantine M tables are classified as regular or not according to regularity condition. It is interesting to point out that although there are infinitely many Diophantine triples, but no algorithm for generating all of them has been found. This problem is still unsolved and only a few partial results have been established. Diophantine triples leads to finding intersection of binary recurrent sequences, which we solve combining the congruence method, linear forms in logarithms, and applying Baker-Davenport reduction. Diophantine M tuples usually involves the theory of Peel or Diophantine equations. Also, Brahmagupta, who is very famous Indian mathematician, created some methods on Peel and Diophantine equation and named it as Brahmagupta identity. There are different methods to prove extendability of Diophantine M tables and also Peel equation. We can mention some of them as determining the solutions by using p-adic fields, determining the solutions by using factorization method on number fields, using the Diophantine approximation method, as I said you before, used by Baker and Davenport, modular arithmetic techniques of Taylor, Wiles, and his co-authors, using linear transformations to determine solutions, using elliptic curves and their rational points to determine solutions, and so on. In this section, I will mention some number theoretic results to use in section 3 and section 4. In the definition 1.1, this definition gives the Diophantine sets and triples determination. I will pass it since I talked about it in previous section. In the definition 1.2 explains the regularity conditions of the Diophantine triples. If the triple satisfies 1.1, then we can say it is regular Diophantine triple. Definition 1.3 is related with quadratic residue. Quadratic residue is determined by 1.2 congruence solution. But you have to know that it is different from the complex residue. It is just related with the congruence solution, and it is given in number theory as a quadratic residue. This quadratic, for the quadratic residue, if this congruence has solution, if 1.2 has no solution, then gamma is called a non-quadratic residue module U. In definition 1.4, I will define new Legendre symbol, which is very important for number theory. Legendre symbol is determined by quadratic residue and satisfy 1.3 as a partial definition. In the theorem 1.1, the quadratic reciprocity law has a big importance in number theory. It is described by two primes and Legendre symbols. These two distinct odd primes satisfy 1.4 equation. Especially quadratic residuosity of 2 module Q is given by 1.5 and quadratic residuosity of -1 module Q is defined by 1.6 equation. The last definition is congruence type, and in here, Diophantine triples are reduced to module 4, and it is called as congruence type clone and represented by like that. Firstly, I will give some numerical D10 Diophantine triples as theorems, which are regular D10 Diophantine triples and non-extendable to D10 Diophantine quadruples. Then, I give main theorems and conclusion in the terms of natural numbers. Let us look at our numerical theorems. In theorem 1, I find a set which satisfies the condition P10. The set is 1, 6, and 15 is a regular triple and non-extendable to D10 Diophantine quadruple. If we look at the theorem 2, a set P10, 1, 15, and 26 is a regular triple and non-extendable to D10 Diophantine quadruple. And in the theorem 3, we can say there is a set and it is 1, 26, and 39 is a regular triple and non-extendable to D10 Diophantine quadruple. These P10 sets seem like a chain. Let us continue by giving some different numerical results. In theorem 4, a set P10, 1, 39, 54 is a regular triple and non-extendable to quadruple, and we can continue like that. And the important thing is we can write many numerical regular D10 Diophantine triples. If you look at the above theorems, you can easily see that triples are coming as if chain rings one after another. This implies that there are D10 Diophantine pairs and all of them are generated by them. And this is our first main theorem. Let this pair set be D10 Diophantine pairs for n equals or greater than 4, then followings are satisfied. The first one, these D10 Diophantine pairs generate these Diophantine triples like you see. In the second, it is easily seen that these D10 Diophantine triples are regular. And the last one, these regular D10 Diophantine triples cannot be extended to D10 Diophantine quadruples. In here, if you put n equals to 4 in the main theorem, we get theorem 1. Putting n5 in main theorem, we obtain theorem 2. Substituting n equals to 6 in the main theorem, we have theorem 3, and similarly we can continue. This shows that our main theorem is both generation and generalization of the some countable infinite regular D10 Diophantine triples. Our first result also haven't been solved before, and they are new results in the literature. Similarly, we can give main theorem 2 for different type of D10 Diophantine pairs. Let these pairs be D10 Diophantine pairs for n greater than 2 or equal, and it is natural number. Then followings are hold. The first one, these pairs generate D10 Diophantine triples, this type of Diophantine triples. The second one, these D10 Diophantine triples are regular, and the last one, these regular D10 Diophantine triples cannot be extended to D10 Diophantine quadruples. If we change a natural number, we will get countable infinity D10 pairs and also triples. As a conclusion of our main theorems, we can give this corollary to find characterization of the element for D10 Diophantine sets. It is Diophantine set. It is useful for all types of Diophantine sets. We can say that there is no D10 Diophantine set written as AXY such that A is written by multiplication of 4, A is written by multiplication of 3, by multiplication of 11, by multiplication of 17, and then and in the section includes references which are useful for our paper, and with this topic you can see some of my papers and collection and books like that. For example, some books and some of my papers on Diophantine sets like you see. And here, there are some academic websites of mine in here, and you can follow me from here, as I said you before. Thank you so much for giving me your valuable time and attend my presentation. I hope it was useful for you. Now I can get your questions if you have. Thank you very much.
Thank you, dear Professor, for your valuable talk. There are many Professor from Hamad from Iran, Professor Manjit Singh, he is from my place. There is Daljit Kaur and many professors attending your lecture. I would like to ask from Mr. Manjit Singh, Hamad, Gurmeet Singh, if they are willing to ask any kind of question, please feel free to ask any question related to her talk. Yes, please.
Yes, I can try to reply their questions if they have. Okay. Yes, I'm waiting for their questions.
Professor Hamad, are you there? Okay. Professor, I have one question from my side.
Okay,
How the number
please.
theory is important in cryptography? I
How
think
number
Mr.
theory
Manjit
is
Singh is
important
there to
for
ask a question.
cryptography.
Yeah.
As we know, there are many kinds of cryptographic systems by making with different techniques. For example, real quadratic number fields are very useful for preparing cryptographic systems, and it is very difficult to break them. And also primes are very important for them. Diophantine equations are very important in crypto systems. There are two types of crypto systems, symmetric and asymmetric. In RSA crypto systems, we use primes, for example. And Diffie-Hellman is also also related with binary quadratic forms and quadratic fields. So all number theoretic subjects are very important for crypto systems, and crypto systems are created by using all kinds of subjects of number theory.
Okay, thank you, Professor. It's a really very nice talk, and I think Professor Manjeet Singh also would like to ask a question related to this one.
Actually, I'm not expert in number theory, so I'm not asking any question.
Okay, dear.
Okay. Okay.
Dear Professor, here is we have 8 papers in this session, and I hope there may be more. And as you know, there is some network problem at different places. As you know, due to lack of connectivity, some of them may be not available here. So you will chair this session for the presentation of delegate. First, paper ID is ICCTIM224, an application Hirota method to study complete integrability of nonlinear evolution in 2+1 dimensions, presented by Mr. Manjeet Singh.
So, Dr. Mayor, first kindly allow me to share my screen.
Yes, please. Yes, please, sir. I am doing.
I'm also facing some technical issues, so I am giving my presentation from my mobile itself.
No problem, sir. No problem. Not big issue. Yes, dear Professor, you can share your desktop and you can start now.
Is my screen visible to you?
I think your screen has been shared with us.
Okay. So this is Manjeet Singh, and I am here to discuss my work on application of Hirota bilinear method for finding exact solutions for nonlinear partial differential equation. And my ID of paper is 224. So I start with my work outline, which is motivation, Hirota bilinear method, bilinear form, multi-Salton solution, Buckland transformation, and Lax pair. All these constitute the parts of my presentation. So the motivation of my work is the Hirota bilinear method is very useful for deriving exact solution for nonlinear partial differential equations. Finding bilinear form is a highly non-trivial process. I mean, it is slightly difficult to derive bilinear form for a given partial differential equation, which is actually first step to apply Hirota bilinear method. And once bilinear form is written, we can obtain a multi-Salton solution for a given partial differential equation.
Dear Professor,
So,
your PPT not showing here.
Hello?
Dear Manjeet, your PPT not showing here.
Okay.
Yeah.
Is it showing now?
Yeah, your mobile app is there. Now please open. Yeah, it's okay now.
So should I repeat my part?
Please keep continue.
Oh, so my motivation for Hirota bilinear method is that Hirota bilinear method is very useful for deriving deriving exact Salton solution for a nonlinear partial differential equation, and deriving bilinear form, which is essential for Hirota method, is highly non-trivial process. Once it is derived, we can obtain the exact Salton solution for partial differential equation. And the application of Herota bilinear method is not only limited to finding exact solution. We can also find Boolean transformations and lax pair for given partial differential questions, which are a strong indicator of the integrability of partial differential equations. So I start with the definition of Herota bilinear method. It is actually operator which is denoted by capital D letter, here we define like a dx of f dot g. Here f dot g is simply a simple notation for the combination of f and g, and d suffix x mean we are operating this d over f and g together with respect to the variable x, and it is equal to fx g minus fgx. And similarly, we can apply its second order like dx and dt, that like with respect to variable t as well. And we can extend its definition to any order like order 3, 4, and 5. Right, like for example, we take example of KP equation like ut 6 ux and so on. We can convert this partial differential equation into bilinear form using this transformation, which can be obtained using usual Penleaf analysis, like u is equal to -2 logarithm phi double derivative. When we substitute this u into this differential equation, we obtain expression like this. And by arranging the terms which are compatible with the definition of Herota bilinear method, we can see that this combination of this term can be written as dx dt of phi phi, and this combination of terms can be written as dx4, that is a Herota operator of order 4, and this can be written as dy of order 2, right? When we substitute these operators into this expression, we obtained a bilinear form for a KP equation like this, like a dx dt plus dx4 plus 3 dy square of phi and phi, right? So this is a first essential step for deriving a Salton solution for a given partial differential equation, and it is actually called a bilinear form for given partial differential equation. And the Herota method actually a Leibniz rule, which we do in our usual differentiation of product of two functions. But here difference is of alternating negative and positive sign. Otherwise, it is just similar to the Leibniz rule of differentiation of product of two functions. So I start with my work like which start with the application of my Herota method on PKP equation, potential Kudamstern-Petrel equation. So I start with converting this partial differential equation into bilinear form using this transformation. U is equal to 2 log f suffix x plus u1. This I have obtained this transformation using Penleaf analysis. When I substitute this transformation into this differential equation by considering u1 equal to 0, which is a seed solution for given partial differential equation, I obtain expression like this. And using definitions of or forms of Herota bilinear method, this expression can be written into bilinear form like this, like 4 dx dt plus dx4 plus 3 dy square of n on f and f, right? So this is my bilinear form for PKP equation. Now I can start finding my Salton solution 1, Salton solution 2, and 3 Salton solution, right? So for first Salton solution, I have to put f is equal to 1 plus epsilon phi 1, where phi 1 is equal to e raised to power xi 1, and xi 1 is actually wavefront of the wave which we are trying to find. When I substitute this f into my bilinear form, which is given at equation number 5, I obtained the dispersion equation like this. And on solving, on substituting and on further solving, I can prove that the coefficient of epsilon square will be equal to 0. And doing some further calculations, I can obtain solution like this, which is a first Salton solution for given partial differential equation, which can be which will satisfy our original partial differential equation. And for 2 Salton solution, we have to modify our f, which will be 1 plus epsilon phi 1 plus epsilon square phi 2, and where phi 1 is like this, and here we have a xi 1 and xi 2 in place of only xi 1. And when we substitute this f into our bilinear form, we obtain two dispersion relation, and doing some calculations, we will obtain the two soliton solution like u is equal to this, right? So xi will be given by relation this. So, and for finding three soliton solution, I need to further modify my f. F can be modified as 1 plus epsilon phi 1, epsilon square phi 2, and epsilon 3 phi 3. And again, we substitute this into our original bilinear form to obtain three dispersion relations. And doing some brief calculation, we can obtain our three soliton solution, which is given by this, right? So once the bilinear equation is obtained, we can obtain 1, 2, and 3 soliton solution by adjusting the definition of f. So further, which is more further application is to derive Buckland transformation using our bilinear form. Buckland transformation are actually transformation between two partial differential equation having common solution, right? We can rewrite our bilinear form number 5 for f and g like this, and using some coupling formulae which are given in this reference, we can write we can combine these expression into expression number 25, and using some other exchange formulae which are also mentioned in this reference, this expression can be decoupled into three set of equations. And doing some calculations, we arrive at this equation number 21, and by substituting dx square fg is equal to 4 lambda fg and dy fg is equal to mu fg into this equation number 21, this will split into three type of equations, equation number 22, 23, and 24, which are actually bilinear Buckland transformation for given partial differential equation. And there are procedures to derive original Buckland transformation from these two from these three bilinear Buckland transformation. And third part of the application of Rota method is to derive Lax pair for a given partial differential equation. Lax pair are actually linearization of a given nonlinear differential equation. I mean, if you have a nonlinear partial differential equation, you can factorize it into two different factors, two different non-linear factors to find its a complete solution. So Lax pair are basically indicator of the integrability or complete integrability of partial differential equation. And we will proceed with the f is equal to rho and g, and we plug it 25 into 22 and 23, and we obtain a series of equations. And under dependent variable transformation, like u is equal to 2 log derivative x and dx square g dot g over f square is equal to ux. It is actually a formula which is given in reference, which I have discussed in last slide. And doing so, we obtain the system of equivalent to 22, 23, and 24 is found to be like this. And we can eliminate rho out of these three equations to obtain only two equations, which are actually Lax pair for a given partial differential equation. And we can prove that on satisfying this condition, compatibility condition, we can derive original equation from 29 and equation 30. Or I mean to say, these are factors of 29 and 30 are actually factor of our original partial differential equation. And original partial differential equation can be recovered by this compatibility condition. And the existence of this pair proves that our original partial differential equation is actually integrable. And thanks. And these are my references which I have used in this research.
Thank you, dear professor. If there is any question from the participant or audience, please feel free to ask. Any question from the audience?
I can ask one question. Thank you so much for your nice talking. I would like to ask you, is there any application of your results in real life? How can we use them?
application of my results is whenever you find a partial differential equation, nonlinear partial differential equation in physical models, I can easily solve those equations for exact solutions. Those are only applications.
Okay, but for real life,
I am also
or
talking about
living
real life
world,
problem.
how can we use them?
I mean, if you have a physical model and that physical model is modeled into some partial differential equation, especially in nonlinear partial differential equation, I can solve that partial differential equation for its solutions. And with that solution, I can understand the modeling of the problem.
Okay, thank you.
Dear Professor, there is one suggestion from my side. If you introduce one or two examples in terms of application and present them graphically and numerical results by using some software like Mathematica, MATLAB, or other software. So this will be very useful to identify this operator to apply in other branches of sciences. Your results.
Sir, I can easily present those things, but in short period of time, those things are not possible to discuss.
Okay. Thank you, Professor.
Those things need
really,
at least 1 or 2 hours of discussions.
Okay. Really, it is a nice presentation. Thank you, Professor. Next paper is ICC-TIM. Next is ICC-TIM 216. Title of the paper is Explicit Exact Traveling Wave Solutions for Novikov Equation Using Riccati Equation Mapping Method. Mr. Manjeet Singh.
So this paper, sir, are you seeing my?
Yes. I can. This is visible, but we have limited time. Time for this presentation is 10 minutes.
So this presentation also deals with the exact solution of partial differential equation, but with some other method. This method is known as a Riccati equation mapping method, because in the earlier presentation I have discussed the application of Hirota method. But Hirota method, the first the problem was to find the bilinear form for given differential equation, which is very, very difficult to find in some cases. But in this case, I can apply a Riccati equation mapping method for finding exact solution for any kind of partial differential equation with much ease, and even using some computational tools like Maple and Mathematica. So in this work, I discussed the application of Riccati equation mapping method. My motivation is in last 20 to 30 years, we have seen numerous number of methods for solving partial differential equations. In those methods, TANH and EXP method, Hirota method were very famous method for solving partial differential equation with much sophistications. And those methods can be easily implemented in Maple and Mathematica softwares. But here we also discuss some other method, which is Riccati equation mapping method, which is can be applied quite comfortably in comparison to those methods. So my interest is to find or investigate Novikov equation for finding its exact solutions. And this equation is actually written by the equation by which is labeled with the equation 1. It is QT, QXXT, and so on. So this equation was first discovered by Vladimir Novikov during a symmetry classification of partial differential equation, and is also a generalization of Kamasa-Holm equation. Right. So in order to apply my Riccati equation mapping method, I have to transform equation number 1 into equation where I can apply my Riccati equation. And to do that, I need to substitute Q is equal to U raised to power 1 by 2. This transformation will help me to apply my method. When I use this transformation, my equation number 1 will reduce to this equation. And both equations are similar. Equation number 1 and 2 are actually similar and are connected by this transformation. When I obtain solution for this equation, I can recover a solution for equation number 1. So in order to apply Riccati method, I need to balance highest and lowest order term in this partial differential equation. Highest term means the term with the highest derivative, and the lowest term means term with the lowest derivative. And the lowest derivative term is u raised to power 4 and ux, and its order is 5n plus 1. And highest order derivative term is u cube and u triple x, and its order is 4n plus 3. And in order to balance the order of these two terms, I need to equate 5n plus 1 equal to 4n plus 3, from where I will get n is equal to 2. Right now, it is possible for me to apply Riccati equation mapping method, and this method starts with the assumption that u is equal to summation I 0 to 2 ait phi I xi I. Here 2 is taken from the value of n, which I have calculated at the previous slide after balancing the order of highest and lowest order term. And here factor phi I is actually solution of this Riccati equation, first order Riccati equations, number 4. And the main point here is that the solutions of these Riccati equations are already calculated. And there are 24 different type of solutions, including periodic, Soliton, and the traveling wave solutions. Right? I repeat, the solutions of this partial differential equation, which is actually first order Riccati equations, it has been solved in literature, and we have established 24 different type of solutions for this differential equation. What we do is we map solution of our partial differential equation over the solution of this Riccati equation. That's why it's called the Riccati equation mapping method, right? So it will admit different type of solutions, the Riccati equation, depending on the value of R, P, and Q. So I come to the next page. First, I have to find the double derivative of phi and triple derivative of phi. You can do it using Maple or hand calculation. And we label these two equations with equation number 5 and 6. And equation number 5 and 6 will help us to find derivatives of u with respect to x, with respect to t, and double derivative with respect to x, and mixed derivative with respect to t, right? And we will calculate all the derivatives which occurs in our differential equation number 2. And we substitute these all expressions into equation number 2. And after doing so, on substituting equation number 3 into 7 using, after substituting equation number 3 and 7 into, again, creating different powers of phi, right? We will have powers of phi from 0 to 11, and we will create coefficients of those powers of phi equal to 0. And in doing so, we will obtain the set of algebraic equations, like a large set of algebraic equations, which are preferably non-linear partial differential equation. And those equations can be solved using Maple program, or you can also solve those equations using Mathematica and even with the open source software like Maxima. And on solving those equations, I will obtain A0, A1, A2, K, and L, right? And based on the different values of P, Q, and R, I will the third equation will admit 24 different type of solutions, which are mentioned in reference 23, and I will use those solutions to construct solutions for my original equation, right? So here I list different type of solutions for P square minus 4Q greater than 0. The Riccati equation will admit solutions like phi 1 to phi 12, right? I means for P square minus 4Q, they will have 12 different solutions for Riccati equations, right? And these are established solutions in the literature, and I can use these solutions into this expressions to construct 12 different solutions for my equation number 2, right? And for second case, P square minus Q square is negative. We will again have 12 different solutions ranging from phi 13 to phi 24, right? And we can resubstitute those solutions into this expression to construct solutions for my original differential equation, which is given at number 2. And by invoking, once these 24 solutions are obtained for equation number 2, And then I can recall solution for my original equation by invoking this transformation Q is equal to U raised to power 1 by 2. And we can have a different variety of different solutions like soliton, like traveling, periodic, and so on for Novikov equations. And I have actually verified those solutions, actually certify my equation using a Maple program. So final comment, the traveling wave solution obtained here had never been reported before. This works tools and Riccati equation mapping method is quite useful tool for constructing exact solution for partial differential equation with much ease, because we can apply this method in Maple or Mathematica. Thank you. And these are some references which are used in my work. If you have anything to ask, you are welcome to ask.
Doctor, thank you so much for your nice presentation again. If there is any question, please you can ask. I think there is no question for you. Thank you very much for your time and for your nice presentations. Thanks a lot.
Thank you, ma'am. Thank you, ma'am.
Yes. And now the presentation ID is ICCTIM 248. The title of research paper, Applications of Advancements in Corrosion and Cryogenics, presented by Haramrit Singh Sithu.
Good afternoon, ma'am.
Hello, welcome.
Good afternoon to all the session chairs and the organizers of this international conference.
Thank you very much.
On computational techniques and intelligent machines. Please make me co-host so I can share my screen.
Okay. We will allow you to share your screen. Please wait a minute.
Sure, ma'am, no issues.
Dear Professor, you can start now. You can share your desktop.
Sure, sir. So my screen is visible?
Yes.
The topic of my research paper is applications of advancements in corrosion and cryogenic treatment. In this presentation, I will give you an overview related to introductions for the various methods that I have used in this presentation, along with the results and conclusions along with the references. First of all, introduction to the corrosion. Basically, corrosion is an electrochemical reaction of a metal with the environment, which generally results in the deterioration of the metal and its properties. Generally, metal used in industries are unbalanced to varying degrees in normal environment conditions due to corrosion. The damage due to corrosion is considered as a significant problem in the engineering field. The national economy has suffered huge losses due to corrosion. The topmost priority in studying corrosion is to protect the metals and their alloys from corrosion. Basically, in the corrosion is the deterioration of the metals as a result of chemical reactions between it and its surroundings. Now, these are general types of corrosions that occur in various metals and alloys. That is general corrosion, galvanic corrosion, stress corrosion, high temperature corrosion, and pitting corrosion. Now, these are various methods that can be used to prevent corrosion from occurring in various metals and its alloys. First method can be changing the material in use. We can change the type of material we are using in the earlier phase. Depending upon the results, with respect to the environmental changes. Further, we can use corrosion inhibitors, environmental measures, sacrificial coatings, and surface modification techniques. Basically, in surface modification techniques, we can use friction stir processing that is generally used to modify the surface. Now, next, second keyword was the cryogenic treatment. Basically, in cryogenic treatment is reported to be a good technique for achieving grain refinement to enhance the corrosion system of various metals and its alloys. Grain growth must be minimized to attain more grain refinement. Now, lower is the temperature, minimum will be the grain growth, higher will be the grain refinement. Basically, there are three types of cryogenic treatment. We can cool the metal around 180 degrees Celsius, that can be called as cold treatment. Second type can be shallow cryogenic treatment, cooling the metal around 160 degrees Celsius. The third phase is deep cryogenic treatment, that is cooling the metal around 196 degrees Celsius. Basically, for cryogenic treatment, we have to cool down the metal for a certain defined time period along with the tempering. Basically, tempering is done to avoid the unbalancing stress induced due to the cryogenic treatment. Now, method in this case, we have choose the Scopus database by considering two keywords, that is corrosion and cryogenic treatment. In this present research study, we have selected around total 421 research papers that were published in this period from 2010 to 2020. This research string was based on Scopus to search annual trends by considering both these keywords along with the authors, subject areas, affiliations, and top countries. Now, this slide shows the yearly publication by considering corrosion and cryogenic treatment. Now, from this figure, it is clear that there was a decreasing trend from 2010 to 2013. As in these 4 years, only 30, 29, 27, 26 publications were published in this field. From 2014, there was continuous growth in the publications, reaching a peak of 59 articles in 2019. But again, in 2020, there was a fall and found to be 52 publications by considering both these keywords, that is corrosion and cryogenic treatment. Now, in this slide, we can see the publication by various authors in the field of corrosion and cryogenic treatment. Now, this figure shows the list of authors who published at least 5 number of publications. Now, this list consists of total 10 such authors. At the top position, there was Mr. Javir IS, who published 18 papers, or we can say 18 articles, followed by Dylan OW, who published 14 articles by considering corrosion and cryogenic treatment. Further, Piliudier, who published 13 articles, and PZ published 14 articles. Meanwhile, Batoni R. Sulsi and Goethe published 10 articles, which can be seen in this figure, and Altio, JC, and Uvula both published 6 articles. These all authors contributed a lot to this field based on corrosion and cryogenic treatment. Now, these are the results for the publications based upon the subject area. Now, the top position under search areas of corrosion and cryogenic treatment with maximum number of publications were in the engineering field and considered to be 32.1% of the overall publications. Material science are at second level. Further, the physics and astronomy were at rank 3 with 13.8 publications. The top research areas were in chemistry 4.3%, and about in energy field 4.3%. For the computer science, mainly focused around 4.2%. whereas chemical engineering about 3.6, earth and plant about 2.3, and environmental science around 1.7, mathematics and others about 2.6, where about mathematics they have used about 1.5%, the combination of corrosion and cryogenic treatment. Now this slide shows the number of articles published by various affiliations. Now the University of Constantine has the maximum number of publications with 19 publications, whereas University of Daegu Study, Padova, and Ministry of Education, China, and Tsinghua University are at second position with 10 publications, followed by Indian research organizations who published 19 research papers in the field of corrosion and cryogenic treatment. For the Chinese Academy of Sciences, published around 8 publications during this period in the field of corrosion and cryogenic treatment. And the National University of Science and Engineering around 7, and Beyond University around 6. The data is shown in figure depending on total number of publications published in the field of corrosion and cryogenic treatment. Now these are the results based upon the country or territory in the field of corrosion and cryogenic treatment. Basically, China published the maximum number of papers, that is around 86, followed by United States, followed by India with a count of 76 publications, and then followed by United States around 70 publications, whereas Italy had published 28 research papers in the field of corrosion and cryogenic treatment, where France 19, South Korea 18, Russian Federation around 7, and Japan and United Kingdom around 13, and Malaysia about 12 publications in the field of corrosion and cryogenic treatment. The basic conclusion of this work was the study explored an interesting research trend on corrosion and cryogenic treatment. As per the best of our knowledge, it will be the first attempt to summarize the corrosion and cryogenic treatment by using bibliometric method. In this bibliometric study, we are focused on total 421 publications from 2010 to 2020 in the field of corrosion and cryogenic treatment. So this was the conclusion. We have studied around 421 publications. These are certain references that we have used in our study based on corrosion and cryogenic treatment. Thank you, please. Any question, any query, you're most welcome.
Thank you so much for your nice presentation again. You have 2 presentations today, yes?
Yes, ma'am. Thank you, ma'am. Thanks a lot.
Okay. You used different methods by finding something, I think, yes?
Yes, ma'am. We have used the magnesium alloy.
Yeah. Okay. Now, if there is any question, we can take, and if not, we will start your second presentation.
Sure, ma'am. I will wait for 1 minute if there is any query.
Is there any question? Maybe you can ask you after you complete another one, okay?
Sure.
For the next presentation, ICCTIM 2062. The paper title is a 22 years bibliometric study based on cryogenic and friction stir techniques, and presented by you again. Yes, please, we can start. Thank you.
Now, the topic of my research is a 22 years bibliometric study based on cryogenic and friction stir techniques.
Dear Professor, please finish this paper within 5 minutes.
Sure,
there are some time constraints, please.
Sure, sir. No issues.
Okay.
Basically, volumetrical is a type of a search method used in library and in information science. It utilizes quantitative analysis and statistics to describe patterns of publications with a given field or a body of literature. Now, basically, friction stir processing. Now, this is the introduction to FSP, that is friction stir processing. Friction stir processing has emerged as an excellent grain refinement process, which is extensively used for the surface microstructure improvements. In FSP, a small pin at the end of rotating FSP cylindrical tool is inserted into the surface of the material. The shoulder of the FSP tool heats up the top surface of the material due to the rotation sliding motion. The pin of the tool that was plunged into the material creates a seeding action and the material grains undergoes recrystallization. Due to this, grain refinement will occur, which will improve the properties of the metals or the alloys. This we have already discussed in the previous paper also. The lower is the temperature, minimum will be the grain growth, higher will be the grain refinement. Grain refinement plays a very important role for improving the corrosion resistance of the metals or the alloys. Again, in this study, we have used Cooper's database. The total 79 publications were retrieved in the field of cryonic and friction stir processing. Earlier, we have studied corrosion and cryonic treatment. In this study, we have used cryonic and friction stir processing from Cooper's database. The present research study was selected between 1998 to 2020 span of time. This research was done on 5th September 2020 based on the Cooper's database. This search string was based on Cooper's to search annual trends, authors, subject areas, affiliation, and top countries. Now, these are the results, or we can say yearly publication trends in the field of cryonic and friction stir. Total of 79 papers are published in the field of cryonic and friction stir during this span of time. They found the mechanical properties of metals can be improved by friction stir processing and further by cryonic treatments. These are the annual trends. Now, these are the number of publications again in the field of cryonic and friction stir depending upon the authors. Now, this list of authors who published at least 2 papers publications with a total of 10 authors are shown in this PPT. At the top position in the list was Lee HS, who published 6 papers in this field, followed by Abghast, WJ, FUR, and LIY, who published 4 papers in the field of cryonic and friction stir processing. Meanwhile, Hartley PJ, Wang Y, UJT, and Zhu were the authors with 3 papers. The 2 authors, Humbert R and Y, had 2 numbers of papers each. Now, these are the trends based upon publication according to a country and the territory in the field of cryonic and friction stir. Again, United States was leading in friction stir and cryonic publications among top 10 countries. The US has the highest number of publications, the count of 24 publications, where China and India had the same number of publications, that is 12, followed by South Korea 7, Japan 6, Iran 4, whereas United Kingdom by 4 publications in the field of cryonic and friction stir. Germany published 3 research papers, whereas Denmark and Italy published 2 research papers in the field of cryonic and friction stir processing. Now, these are the top affiliations who published the research in the field of cryonic and friction stir. This figure shows the Korea Aerospace Research Institute publishing the highest number of papers, that is 6, where NASA Marshall Space Flight Center, Yonsei University, and University of Science and Technology UST had the same number, that is 5 number of publications in the field of cryonic and friction stir, followed by the National Aeronautics and Space Administration, Sharif University of Technology, Korean Institute of Material Science, and MT Aerospace with the same number, that is 3 publications in the same field, that is cryonic and friction stir processing. These are the trends based upon the subject area.
Professor, please conclude the paper.
Sure, sir. Now, basically, bibliometric study was performed for a total number of 79 publications for the span 1998 to 2020. Based upon the results, we have described all the aspects depending upon the author, subject area, affiliations. Cryoning of friction state was highly published in the engineering and the other streams than the other streams. The source with the highest number of publication is ASM Proceedings of the International Conference Trends in Welding Research. Through the analysis of keywords, 6 clusters were found in the result. These clusters represented various keywords used in different publications along the cryonic and friction state. Cluster 1 represented the combination of maximum keywords such as aluminum alloy, crack growth rate, dissimilar metals, welding, fatigue crack, fracture toughness. Basically, all these are the mechanical properties related to the materials. These are certain references that I have used in my study. Hi, thank you, please. Any question, any query?
Thank you very much for your valuable presentation. You shared very nice information with us. If there is any question, please you can ask. Thank you very much. I think there is no question for you. Thank you so much for your attending our conferences with your valuable presentation. Thanks a lot.
Okay, thank you.
Okay, thank you very much. And we will continue with the next presentation. The idea of the presentation is ICCTIM 261. The title of the presentation is Notes on the Value Distribution of Transcendental Integral Functions of Difference Polynomials, presented by Hüsna.
So very good afternoon, madam.
Good afternoon. Hello. Thank you so much for your attending our conferences.
Thank you, ma'am.
Yes.
Please.
Okay. You will share your presentation, but give us a minute, please.
Ma'am, please allow me to share the presentation.
Okay. I will allow you. Please wait a minute.
Is it visible, ma'am?
I think yes, you can. Yes. We saw your presentations. Yes, you can start if you are ready.
So very good afternoon to one and all. My name is Nagarjunvi. I'm doing my research under the field of Nevelina theory under the guidance of Husna, Department of Mathematics, Presidency University, Bangalore. My title of the presentation is Notes on Value Distribution of Transcendental Integral Function of Difference Polynomials. The abstract of this paper is as follows. In this present research paper, we are going to investigate the uniqueness problems and the zeros distributions of Q-shift difference polynomials of entire function. And this paper extends the results of Libao Long and Zhunfang Zhu. So the introduction. So in this paper, we are going to use the basics of Nevelina theory, such as MRF, NRF, and TRF, where MRF is the proximity function, NRF is the counting function, and TRF is the characteristic function. As usual, TRF can be written as sum of counting function and proximity function. And not only this, we are also using the definition of Q-shift function f of z, and it is defined by f of qz plus c. And we are also using the definitions of ignoring multiplicity and counting multiplicity. If f of z and g of z are two meromorphic functions, have the same zeros with the same multiplicities, then we say that it is counting multiplicity. Otherwise, it is called as ignoring multiplicity. Also, we are denoting NP of R1 by f minus a, the counting function of zeros of f of z minus a, where an m-fold zero is counted m times if m is less than or equal to p, and p times if m is greater than or equal to p. So in 2020, Libau law, the motivation of this paper is in 2020, Libau law and Junfeng Zhu had proved the following these two results, theorem A as well as theorem B. The theorem A is stated as he considered f of z to be transcendental entire function whose order is 0 and the value of qj, j ranging from 1 to t be non-zero finite constants and sigma is equal to summation j is equal to 1 to t mu j belongs to n plus. If the polynomial p of omega is denoted by this, where a1 to a0 are constants, then f power n p of f product j is equal to 1 to t f of q j z mu j minus alpha of z has infinitely many zeros. Especially if p of omega is identically equivalent to c naught, then the result holds good for n greater than or equal to 1. And the theorem B, he considered two functions f of z as well as g of z to be transcendental entire function whose order are 0 and the value of n is greater than or equal to L plus H sigma, where sigma, mu j and P of f are defined in theorem A like this. P of omega, mu j are defined in this theorem. If f power n p of f product j is equal to 1 to t f of q j z mu j and g1 is equal to g power n p of g product j is equal to 1 to t g of q j z mu j share alpha of ZCM, then one of these two condition holds, that is condition 1 and condition 2. So in my main theorem, I proved the result holds good for kth derivative also. And the statement of the theorem is as follows, that f of z be transcendental entire function whose order is 0 and the value of qj, j is equal to 1 to t, be non-zero finite constants and sigma is defined as j is equal to 1 to t mu j, where mu j belongs to n plus and the polynomial is defined as usual way, and where a1 to a0 are constants. If n is greater than or equal to 2, then f power n p of f product j is equal to 1 to t q f of qjz mu j kth derivative minus alpha of z has infinitely many zeros, especially if the polynomial p of omega is identically equivalent to c naught, then the result holds good for n greater than or equal to 1. The theorem 2, here I considered two functions f of z and g of z are transcendental entire function and the value of n is greater than or equal to L plus H sigma and f power n p of f product j is equal to 1 to t f of q j z mu j kth derivative and g power n p of g product j is equal to 1 to t g of q j z mu j kth derivative share small function alpha of ZCM, then one of these two condition holds. So remark, if k is equal to 0, that is when I put 0, k is equal to 0 in theorems 1 and 2, then theorems 1 and 2 will get back to the theorems A and B. So these are the some lemmas I have used to prove my main results. Lemma 1, here I considered f of z to be meromorphic, then the proximity function of mr of f of qz by f of z is equal to SRF. In lemma 2, so TRF, the characteristic function TRF of QZ is equal to TRF of Z. And when I take characteristic function to the polynomial TRP of F, then TRP of F can be written as P times TRF plus SRF, where P is the highest degree in the polynomial. This is the important lemma I have used. Here I am considered two functions f of z and g of z to be meromorphic. The two functions f and g share 1 cm. Then one of these conditions holds, and TRF given by this inequality, and f of z and g of z is identically equivalent to 1 and f of z is identically equivalent to g of z. And this lemma 5, so here I have proved f power n p of f pi ranging from product j is equal to 1 to t f of q j z mu j is identically equivalent to g power n p of g product j is equal to 1 to t g of q j z par mu j. Then one of this condition holds. So this is lemma 6. So NP, where here I'm considering f of z to be non-constant meromorphic function and two integers p and k, then one of the condition holds, one of the inequality holds. This is lemma 7. So two functions f of z and g of z are transcendental entire, and P of f, sigma are defined in theorem as usual way. If f is equal to f power n P of f, product j is equal to 1 to t f of q j z mu j at kth derivative, and g is equal to g power n P of g, product j is equal to 1 to t g of q j z mu j kth derivative, if there exist two non-zero constants C1 and C2 such that n bar R C1F is equal to n bar R0G, n bar R C2G is equal to n bar R0F, then the value of n is less than or equal to 2k plus L plus sigma plus 2, where n bar is the reduced counting function. And these are the references I have used in this paper. Thank you. Thank you, ma'am. Any questions?
Thank you. Thank you so much for your nice presentation and for your contribution to our conferences. If
Thank
there
you,
is
ma'am.
any questions, we can ask to Hüsna. Is there any question to ask?
मैं बल्कि जसविंदर ਨਾਲ ਲਾ ਕੇ ਤੇ ਰਾਜਵੀਰ ਮੈਮ ਨੇ ਤਾਂ ਸ਼ਫਾਲੀਆਂ ਦਾ ਨਾਮ ਵੀ ਨਹੀਂ ਲਿਖਿਆ, ਸ਼ਾਇਦ ਇਹਨਾਂ ਦਾ ਪਿਛਲੇ ਸਾਲ ਵੀ ਦਿੰਦੇ ਤੇ ਲੜਕੇ ਦੇ ਕੱਢਿਆ ਚੇਅਰਮੈਨ ਨੇ ਸ਼ਫਾਲੀ ਮੈਡਮ। ਮੈਡਮ ਤੁਹਾਨੂੰ ਪਤਾ ਹੀ ਨਹੀਂ ਕੀ ਕੁਛ ਹੈ, ਜਸਵਿੰਦਰ ਨੇ ਬਹੁਤ ਕੁਛ ਕੀਤਾ। ਮੈਨੂੰ ਤਾਂ ਐ ਸੀ ਕਿ ਜਸਵਿੰਦਰ ਨਾਲ ਤੁਹਾਡੀ ਬਣਦੀ ਬਹੁਤ ਹੈ, ਰਾਜਵੀਰ ਜਸਵਿੰਦਰ ਨਾਲ ਮਤਲਬ ਸੀਰੀਅਸ। ਮੈਡਮ ਮੈਂ ਤੁਹਾਨੂੰ ਦੱਸਦੀ ਨਾ, ਰਾਜਵੀਰ ਦੀ ਪ੍ਰੋਬਲਮ ਆਈ ਸੀ ਫਾਈਨਲ ਸੈਸ਼ਨ ਚ, ਮੈਂ ਉਹਨਾਂ ਦੀ ਵਿੱਚ ਕਹਿੰਦੀ ਸੀ ਮੈਂ ਟਾਈਮ ਟੇਬਲ ਚੇਂਜ ਕੀਤਾ, ਮੇਰਾ ਵੀ ਲਾਲਚ ਇਹ ਸੀ ਕਿ ਮੈਂ ਨੀਚੇ ਹੋ ਜਾਊਂਗੀ ਤਾਂ 500 ਸਰ ਇੰਨਾ ਕੁ ਕੋਆਪਰੇਟ ਕਰ ਦੇਣ ਕਿ ਮੈਂ ਇੱਕ ਚੈਂਬਰ ਲੈ ਲਾਂਗੀ ਉੱਥੇ ਸਟਾਫ ਦਾ, ਤੇ ਮੈਂ ਬੈਠੀ ਰਹੂੰਗੀ ਉਹਦੇ ਲੈਕਚਰ ਲਾਂਗੀ। ਤੇ ਰਾਜਵੀਰ ਨੇ ਆਉਂਦੇ ਕਿ ਮੈਡਮ ਬਾਲੇ ਆਪ ਨੂੰ।
Thank you, all of you. Dear Professor, please conclude the session. Dear Professor Ozar, I request you
Okay,
to conclude the session. Yeah.
Hello, Professor.
Okay.
There are 3 papers. These 3 papers will be presented in the next session, which will start at 3:15. Okay. The session is 10. So please, dear Professor, conclude this session, and then after the paper will be presented in the next session. You can conclude now.
Yes, dear Professor, we thank you for your contributions and we wish you successes in your future works. Thank you so much for all and see you in the next session. Thank you very much.
Dear all participants who did not present your paper in this session, because there are some time constraints, so I will request you to join next session. Session number 10, and link already has been sent on your email address.